This episode of Fluid Power Forum is sponsored by Endeavor AI. Endeavor AI automates order entry, quoting, and the quote-to-cash process. Win more, sell more, and save time, all without adding headcount. Head to endeavor.ai to learn more. This episode of Fluid Power Forum is also sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of the show, as always, we ask that you follow us on LinkedIn. You'll find us there at the National Fluid Power Association. And make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with our hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You'll find us on Apple Podcasts or on Spotify or on any of the other popular podcatching services. We're everywhere. Wherever you find us, please subscribe to the show and then give us a quick rating. Those ratings really do help promote the show and allow more and more of our friends in the industry to join in on these important conversations. On today's show, my guest is Marcus Herrera, an advanced systems application engineer at HYDAC. Founded in 1963, HYDAC has become an industry giant, present in a wide swath of industries with products ranging from controls to actuation. And today our focus is going to be largely on energy efficiency, which is the topic of a recent NFPA white paper. Marcus was a key contributor to that document, and so we invited him into our forum to help us take a closer look at some of the important points in that document. So Marcus, welcome to Fluid Power Forum.
Hey, how's it going, Eric?
It's going well. We're glad to have you on the show, and I'm excited to talk about energy efficiency, especially for hydraulic systems.
Let's do it then.
Great. Tell our listeners a little bit more about yourself before we dive into that. What is your background? How did you find yourself working at HYDAC?
Well, it all started back in college. So I, graduated from Iowa State in mechanical engineering, and I don't know if you know much about Iowa State, but that's an AIM. That's an Ames, Iowa.
I've been there many times. Yes.
Good.
Yeah.
Good. So those in the industry probably also know that Danfoss is there. So
Right.
I started my career at Danfoss. I did 4.5 years in sensor application. It was mainly pressure and temperature sensors that I supported.
Mm-hmm.
And the Ames location is their hydraulics division. So my main role was basically to bring their sensor stuff to the hydraulic applications. Later, I transitioned to HYDAC out in Illinois. We're kind of in everything's Chicago here, right? But
Yeah.
Glendale Heights is our actual city, where I continued to do sensor application. And then about 3 years ago, I transitioned into the systems role. So then I started looking into, general system stuff. So that included batteries, battery thermal management. And now we're talking about energy efficiency and hydraulics.
Yeah, you've got a wide range of experiences, it sounds like, in different technologies, all related to fluid power and hydraulics.
I do, and I
Yeah.
love how small the industry is, right?
Right.
You make some friends along the way, and we run into each other all the time.
No one ever leaves the industry. They just move from company to company. Exactly. Right. Right. Well, that's great. So as I mentioned in the opening, NFPA, and with a lot of help from you, recently published a white paper describing some of the ways for hydraulics to save on energy efficiency for hydraulic systems. Let's start talking about that. What problem was this paper trying to solve? Why did we go down the road of putting this paper together?
So I'd say probably in the last 5 years, we've heard the buzzword electrification, right?
Yeah.
We've seen, especially 2 Con Expos ago, it was everywhere.
Yeah.
I think at the last Con Expo in 2026, maybe not quite as much, but I would say in general, around electrification in general, there's a little bit of uncertainty. How am I supposed to size my components? Why is it important? How can future advancements actually like play a role in my machine, right? So this paper was really not to convince anyone to electrify a machine. It's actually more giving NFPA members a resource for kind of like a guideline on things they should consider if they decided to go down the path of electrification.
Well, an electrified vehicle, has a lot of different demands on the hydraulic system than in one driven by an IC engine, right?
Yes, absolutely.
And that's a big piece of this as well. I guess we should note for the listeners, if you are interested in taking a look at this white paper, we're going to put a link to where you can download it in the show notes. So if you're listening along and you'd like to take a look at it, please go ahead and do that. So Marcus, what are some of the key drivers for electrification right now?
Well, I'd say the reason that energy efficiency is important is when you look at the conventional power source, right? You have a diesel tank, and when you run low on energy, it's as simple as adding more fuel to keep going, right? But when you start talking about electrical machines, that energy on board of that machine is fixed, and it generally takes a lot longer to charge a battery than it does to fill up a diesel tank. So
Absolutely.
how you use the energy on the machine effectively and efficiently now becomes critical. It really determines whether or not that machine is capable of doing the job, or whether you need to stop and go charge that machine to finish.
Marcus, where do you think the OEMs are in this process of electrification? Like you said, maybe not as prevalent at the most recent Con Expo than it has been in the past. Is there still some hesitancy out there from the OEMs to electrify their vehicles?
I would say so, yeah. I think there's a balance between like maybe, so let's say innovation versus uncertainty, maybe is a way to phrase it. So there's a couple of things here. Let's first start with performance. The one big question is, okay, if I take my diesel engine out and I put a battery in, is my machine going to do what my old engine used to do? Is it actually going to perform the way it needs to? And another thought around that is, if I do I have the infrastructure around my machine to support charging my battery, or is that going to be a limit if my machine's out in the field? Then there's some cost and supply chain maturity issues. There's not a lot of people in industry. We talked about, it's a small industry. Everyone knows each other. Everyone knows what each other's working on.
Right.
And so you look at that field and the different suppliers that are out there. There aren't very many people that are making electrified components, the batteries, inverters, motors. And so I think in general, customers are probably waiting for more suppliers to get on board and provide more solutions out there. And then I think lastly, and this is the biggest point, is market acceptance, right? We know that these machines right now are going to be a higher upfront cost. So it's really a question of like, what are the long-term benefits? Where's the benefit to the customer? So I would say, the hesitation, it's probably not necessarily resistance to battery-powered machines or maybe alternative power machines, but it's more cautionary.
Yeah. Yeah, it's important, I think, whenever we talk about this subject, and you alluded to it there with regard to the availability of electrical components for these machines. When we say electrification, we're talking about the prime mover primarily, not the actuated functions on the machine, right? So this is really replacing the IC engine with a battery pack or a motor of some kind, or some sort of electrical power supply, right?
That's a really good distinction to make. Yes. Yeah. In the very beginning of this paper, we kind of got together as a group within NFPA and had a discussion of what we wanted this paper to be about. And you hit it exactly there, right? We're talking about an engine replacement, an ICE engine, internal combustion engine replacement with either batteries or fuel cells or another alternative solution than, running diesel or gasoline. So throughout the paper, I'm probably going to say the term battery quite a bit, but that could be battery, could be fuel cell, just something alternative to ICE.
There's a lot of different structures out there that are being used in that space. But energy efficiency is one of the main drivers for that change as well. Can you talk about the efficiency profile of the diesel system versus the battery system?
Yeah, sure. I think what's really important to distinguish really is the effect of inefficiencies of an electric power source versus the conventional power source. So I'm actually, if for those of you following along on the paper, there's a bar graph that's going to come up, and we're talking about the differences between conventional and electrical power source and what that train looks like from power to workforce or actuation, right? So just a quick, for those listeners who don't have the paper in front of you, on the conventional power source, we're talking about a diesel tank full of diesel, and that represents 100% of the potential energy in the machine, right? Then that goes through the engine, goes to the valves and pump, and then finally at the working function. So when we look at that stack, right, coming from my diesel tank going into my engine, almost immediately, 65% of the energy is immediately lost when it comes to exhaust and heat and noise, right? So the available energy available to do work is greatly reduced from the very beginning. Once you factor in pump and hydraulic losses, that at the end of the day, when you actually get to, let's say it's a bucket, right, you're only left with 18% of the total system energy available to do work.
Yeah.
So another way to think about that is like a less than a fifth of the energy that you start with is useful for work.
Right.
Now, if you compare that to an electrical system, you know, instead of now a diesel tank, we're now looking at a fully charged battery. Well, your motor and your inverter efficiencies are significantly higher than your ICE efficiencies. So at the end of the day, when we go back to that bucket, from that battery, we're actually looking closer to like 45 to 50% of that energy being used productively.
And that savings is mostly from the switch from internal combustion engine to battery pack? Or
exactly that.
Are there also savings in terms of well, there must be some savings with regard to the hydraulic system then as well, right? That's a big point of the paper.
I think the key here is to say how important the efficiencies of the hydraulic is, right? So if we took the standard hydraulics on an ICE machine and directly just swapped out a battery, you're going to find that your machine may not do what you were hoping it to do. So let's walk through this. Let's pretend that we improve the hydraulic efficiency by 20% and compared to what we were just talking about, right? So in a diesel engine, that 20% correlates to a 6% more usable energy, right? Because at the end of the day, I guess I should probably give you some a little bit more numbers for the audible listeners.
You're starting with a smaller number at the start of the right. I get that part. I think I get that part, right?
You do, exactly right. So because of your efficiency of your hydraulics, you're starting at 18%. When you increase it by 20, you're only getting up to 24% of that usable energy. But on the electric machine, we're talking about a 50% decrease, so we're about 46%. That extra 20% of efficiency gain from those hydraulics actually relates to 61%. Yeah. So another way to think about this, the same 20% of hydraulic efficiency improvement between the two is more than a double impact from the available energy on that machine. And so let's correlate this to why that's important, right? In real terms, that's the difference between either your machine going from a 6-hour to an 8-hour shift, or maybe you can reduce the number of batteries or the size of batteries, which, between you and I, if we're honest, that's the majority of the cost of the system.
Yeah.
So efficiency, I guess, in hydraulics isn't necessarily like a nice to have. It might actually be one of those levers that determines whether the machine is even viable for a conventional or for an electrical power source.
It's really the most critical driver, it sounds like, in that decision to move to an electrified platform. If you can't get that energy savings, then what's the point of doing it? Right?
Great question. Yeah, exactly. Yeah. I would totally agree with that question. Yeah.
So that's creating a lot of opportunity. I've seen other presentations before where a lot of the things that are changing in the hydraulic system architecture or how the hydraulics are laid out are not new ideas. We've had the capability of doing these things for a long time, but there hasn't been the incentive, like you just described, to actually. There's a little bit of extra cost, I think, that goes into some of those things, but that's more than made up for because of the energy savings. Did I hear that right? Is that a fair analysis?
That's a fair analysis, and it's not only upfront component costs, but it's also the burden on the engineering team to like have to dive in and
Sure.
even consider redesigning their current machine, right? So some of these guys, they're really cognizant of their next model year coming out on time. And if we start talking about changing the whole architecture, there's going to be a lot more work, even just to do from the engineering standpoint. So
Right.
it's not just component cost; it's also all the stuff in the background.
Well, the paper I know goes into several examples, if you will, or things to do differently with your hydraulic system to realize some of those efficiencies. One, really, there's a lot of information there about making sure your motors are properly sized. And do you want to go into any detail on that, or is that any more information you can share on that piece?
It depends if the listeners want to have like a 3-hour podcast or like a couple 30-minute, but at a very, very high level.
It shouldn't take you 3 hours to read the white paper. It's not that long, right? So
I'm a slow reader, Eric. I have to read it a couple times over to understand what I'm reading. But
all right,
at a very, very high level, I think when we're talking about the sizing portion of the paper, we talk about the difference between sizing an ICE engine. You usually use the term corner power. When you size electric components, that's no longer a consideration, because now we're talking about continuous or intermittent operation, so S1, S2 operation. And then because we're talking about that, now there's some thermal considerations. So it's a high level overview for those who want to read the paper, who have decided to go electrification. Maybe they're a little bit overwhelmed or they don't quite understand how electric motor sizing works. It's just a quick overview of maybe some things to consider.
We'll continue with our guest in just a moment, but first I want to tell you about an opportunity to engage in the future of fluid power technology. Two of NFPA's most active committees are our two technology task forces, one focused on mobile applications of fluid power, the second on industrial applications. Each of these task forces work on a series of projects that help us better understand the technology trends in these sectors and help us develop the resources and connections that will be needed to keep fluid power positioned as an actuation technology of choice on both mobile and industrial platforms. The Mobile Task Force publishes a series of reports. Their latest was on ways to design more energy-efficient fluid power systems for mobile equipment with electrified prime movers. The Industrial Task Force also publishes reports. Their latest was on ways to minimize and prevent leaks in fluid power equipment. And they have also completed a year-long project that created an independent technology roadmap specifically for fluid power in industrial applications. All of these resources are accessible on our website at nfpa.com/technology reports. But more important is your ability to participate on and engage with the technology professionals that serve on these task forces. New working groups are forming now around the use of sensors and data analytics in fluid power systems, as well as many other cutting-edge technology advances. These task forces are a great example of NFPA's effective forum in action, with NFPA members across the supply chain and an increasing number of their OEM customers actively engaged in creating the technology strategies that help all of their businesses grow. To learn more and to get involved, contact me at elanke@nfpa.com. Okay. Well, I know another area, another common theme is the metering losses. Talk to us a little bit about what that is and what are some ways of dealing with that.
Yeah, sure. So there's an OEM off-highway article that I found when I was writing this paper that I felt like summed up losses in the machine really, really well. So there's a graphic there that talks about mini excavator losses when you consider the duty cycle, and they estimate that over 50% of the losses in total on that machine come from metering losses. So at like a high level, metering loss happens anytime you try to control the motion of the vehicle by restricting flow, right? So essentially we're taking useful energy from that hydraulic flow and we're turning it into noise and heat because we're restricting it in some way. The unfortunate thing is that it is required for hydraulic systems to work properly. So just really quickly, I'll talk on what metering in and metering out are.
Sure.
And we'll start with metering out. that's when you're trying to restrict fluid leaving a cylinder. So a really good example of this is, let's go back to my excavator. If I have my bucket in the air and I want to lower it down, usually I have a load holding valve in there. Now, the reason I have that is it's sized for when the bucket is full. Let's say I'm picking up rock. If I lift that bucket up in the air and I let go of my controls, I don't want my bucket to slam against the ground, right? I need to have some sort of something to hold that bucket up. Typically, that's a load holding valve. So if we consider the same architecture, there's an excavator bucket in the air, but that bucket is empty. That valve is still sized for the fully loaded bucket, right? So instead of letting gravity help me, I have to actually pump more energy from, I have to add more energy into the system to decompress that spring to let the bucket lower, even if I don't have load. Now, metering in is the other side of the actuator, right? So now we're restricting flow going into the cylinder. You'll see this when you're trying to slow down or make really precise movements. Maybe you're doing multiple functions. So basically, the idea here is the pump is sized, like we talked about, usually for the most flow or pressure it's going to need for that function.
Right.
So I might need to restrict that flow going into that actuator to control that speed through, valves or orifices. I guess I'd say in summary here, the goal of the electric machine, because we know that we need these restrictions in order for our functions to operate effectively, the goal should be how can we command these restrictions more intelligently and maybe limit these losses as much as possible.
Yeah.
And I would say, in the paper, we go through a couple examples at a very high level, I guess a one sentence summary here.
Yeah.
You might see the way that we can increase these efficiencies is by using something like a pilot control valve, or even better, a proportional control valve to dynamically match the load based on the restriction based on the load, right? So in the example of lowering the bucket down, if I can detect that I have no load in that bucket, then I can move that proportional load holding valve so that I have to overcome a lot less spring pressure.
Right, yeah.
Does that make sense?
Yeah. And is it true that the metering losses are like one of the largest kinds of losses in a hydraulic system typically?
Yeah, I'd say in summation, it's like from the OEM off-highway article, it's over 50%
right.
are metering losses. So, and again, but it's a necessary evil, right? I have to have some way to control that flow. Otherwise, my machine's just going to go, crazy. Right. So they are required. It's just how do we do it more effectively?
So minimizing them as much as possible is a good strategy in this regard. You talked about control there just a second ago. I know software and controls are another area that the paper talks about that can really be a differentiator for the performance of these machines. Can you talk a little bit about that? What are some of the things that we're seeing in that space?
Yeah, great question. I think I want to start by saying the hydraulic market has for decades demanded simple, reliable, dependable, easily repairable, right? Easily maintained vehicle. These will never change. No matter how much electronics you put on a vehicle, all of those things still need to stay true. But I think in the last couple of years, we've seen the market, trend more towards having software as a differentiator compared to, the competitors in the market. And, relative to this paper, software can definitely help increase energy efficiency of the machine. If we focus on just position sensors, for example, the position sensors typically are either linear position inside the cylinder, angle sensors, or maybe inclination. These can enable pretty cool stuff when we talk about machine function. So I'll give you two quick examples.
All right.
One of them could be if you're sitting down and you're trying to continue to command that bucket up and the cylinder is already at max position, well, without sensors, my pump is still going to throw flow over a relief valve. It doesn't know that it can't move anymore. Mm-hmm. But if I have a sensor there and I say, hey, that actuator is all the way at end of stroke, I know that my user is commanding, but stop giving flow because it's not needed right now. So the machine can basically stop it from trying to do the impossible. Another example on the same idea, right? We have an end of stroke, maybe fully extend or fully retract that cylinder. Typically, the way that it works is you put in a mechanical it's called a pulse snubber. So it helps protect the end stops from having a huge surge of pressure.
Right.
So that's a fixed mechanical interface that has to go inside the flow. If I had a position sensor, I can detect, hey, you're getting closer and closer to the end of stroke. I'm going to automatically derate your command so that there's a nice soft stop, kind of like soft stops in your kitchen counters, your drawers.
Oh, yeah, right.
So it stops the machine from, vibrating itself apart basically, and it keeps those cylinders and the rest of maybe your pins a lot more safe.
Yeah. That sounds like you're getting close to automated functions on these mobile machines. Is that another strategy that we're talking about?
Absolutely. Yeah. And I would say in general in the industry, automation sometimes is an overused term. And
Yeah.
I feel like you might see the term user assist functions or user assist features. And I think that's the same thing, right? It's a big differentiator for the people that have the sensors and have the controllers and have the software. These machines can help automate those complex, repetitive tasks. And not only is that going to reduce fatigue, it's really going to reduce the skill barrier to run that equipment effectively, right? If I put myself in an excavator and I tried to dig next to someone who's been doing it for 20 years, there is probably a 0% chance that I'll be as good as him.
Yeah.
But if I have some software on my side that I click a button and move a lever and it does something automatically that he has to do manually, well, now all of a sudden I'm a lot better, right?
Yeah.
For those of the guys who've been in the industry for a while or seen the HYDAC booth, one of the things that we show are a couple of these things through, like one example is virtual e-walls, so I can prevent dangerous overshooting of an operation. But then we also have things like an auto grade feature, right? So instead of commanding 3 different cylinders with 2 joysticks, so that's 3 degrees of freedom all at once. Maybe I click one button, move a joystick, and I'm commanding speed instead of position.
Yeah.
So user assist functions, I think, are becoming more and more prevalent today.
Well, yeah, and importantly so. I mean, it seems like that guy with 20 years experience is becoming harder and harder to find, right?
And more expensive.
And more expensive, right? So, so making sure that a quote unquote inexperienced operator can still operate as efficiently through these user assist functions is just really critical and a big part of the energy savings that you would otherwise not see, it sounds like.
100% agree.
Yeah.
Yep. Good summary.
So how do you see kind of all of these things working together as a system? Electrification, hydraulics, controls, software. How does that all work together in the system?
So the title of this paper is Energy Efficiency and how it's important in an electrified vehicle. But I really do think this question is kind of the core message of the whole paper. I think there's multiple sections where we dive into each of these individual, but at a high level, none of these technologies deliver the full value all on their own. There has to be some sort of integration that really drives all of these pieces to work together. When you have electrification, now you have a more efficient power source. When you have hydraulics that are more efficient, you can utilize that energy to a better degree that's already on your machine. And when you have controls and software, you get to more tailor how that energy is being used and how efficiently that energy is being used. So really, electrification, hydraulics, controls, software, they're all wrapped together in this, let's call it like a feedback loop maybe.
Yeah.
Sensors are measuring what's happening. Software is determining what to do with that sensor data. Controls are executing those user assist functions in real time. So, and now we're no longer asking the operator to continuously monitor, adjust, and improve how that machine's operating. We're putting a lot of the onus on that into the functionality of the machine itself. And that's really where it's almost a step change in terms of the energy efficiency on these machines.
Sure. Well, and it sounds to me like, that systems level approach as you're describing can be challenging for certain companies in the industry already. It's like, it's a new way of thinking about your products and where they fit, right? So what do you think would separate a successful company in this space from one that would be less so?
Yeah, you hit it. You perfectly, right? It's really how they approach the system, not just trying to choose the cheapest component, right? There needs to be a consideration for how these components are working together, and not necessarily just relying on legacy designs that have been out there for a while and throwing in a battery or a motor and calling it a day, right? I think we're really in this paper challenging our listeners to really rethink the machine from the ground up. Look at energy efficiency, look at controllers and software and hydraulics, and how do they work together? And I think that's really how you can paint the full value picture of your machine. We've stated this earlier, electrification is going to increase upfront costs. I think the winners out there in the electrification space and in battery machines, they're going to be the ones who can clearly communicate advantages of electrification, not only on their particular industry, but also on the machine and, total cost of ownership. And I would say, in general, what's really neat about this is once you have the sensors and the controllers in place, software is a value add that can continue to go on that machine, right? So in 1 year's time, I can flash new software with that can do more than that machine could do from the beginning. So these machines really can, if they're designed properly, improve over time and become even more efficient than the longer they're in the field. So I think a differentiator isn't just electrification itself. It's like, how do we continuously integrate, optimize, and evolve the machines once they're in use?
That's a great point, Marcus. Yeah, absolutely. And as we said earlier, we are putting a link in the show notes to this episode where people can download this paper that we've been talking about. I feel like we've kind of just scratched the surface with regard to the content and the information that's included in it. Any closing comments for the audience, Marcus, about what they can find there or why they should pay attention to it?
Well, I think, they should pay attention to all NFPA resources. I love your new website layout, and I love being a part of the technology forums and getting to hear from the industry what's going on. And then I'd also say, if there's any just questions about what you're reading, something doesn't make sense, or actually, even if you find an error, reach out to Eric and I. We would take those questions anytime and love to have a discussion in more detail about it.
Absolutely. We appreciate that. Yeah, hopefully. And please, if there's errors, I'm the first person to call. So it's probably my fault.
Hey, but if it's on my paper, I have some onus, don't I?
I know. I'm sure they're perfect in all regards. So great. All right. Well, we appreciate your time on the show today, Marcus. And we look forward to talking with you about future projects.
Perfect. Thanks, Eric. Appreciate your time.
All right. Well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Marcus Herrera of HYDAC, who has been my guest on this episode. If you want to connect with him, the best way to do that is to send him an email, and we'll put a link to his email address in the show notes for this episode. As we said, if you want to check out NFPA's full white paper on the topic we've been discussing, energy efficiency gains for electrified hydraulics, you can do that via the link in the show notes, or go to nfpa.com/technology reports. And you'll find a lot of resources there, including this white paper under energy efficiency. Remember, if you like our show, and we hope you do, please follow us on LinkedIn. You'll find us there at the National Fluid Power Association. And please keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly want to hear from you about the kind of topics we should be addressing on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.